Hi guys, this is Miss Gold. Today's lesson is Module 6, Lesson 4, Real World Area Problems. And your outcomes for today's lesson are students determine the area of composite figures in real-life contextual situations using composition and decomposition of polygons in circular regions. And students determine the area of composite figures and of missing regions using composition and decomposition of polygons. What I'd like you to do first is get a little bit of review. So I want you to complete the warm-up problems on your own. To do that, you're going to want to pause this video until you have completed those problems. Some of the equations may need some of the equations I have listed below. You have area of a triangle, parallelogram, area of a regular polygon. Now within that, realize they've highlighted a triangle within that. So you're going to want to find the area of the triangle and then multiply it by the number of triangles that are in that polygon. Then we have area of a circle, pi r squared, but notice you only have half of a circle. So you're going to want to take the area of your circle and divide by 2. So go ahead and complete those warm-up problems and pause the video until you're ready to move on. Okay, so here are your solutions to your warm-up problems. Notice in particular for your regular hexagon here, we divided this up so I wanted you to see what the different triangles are, or rather how many triangles are in this hexagon, and it comes out to be 6. So we took the area of one of the triangles and then multiplied it by 6 to get the answer. So take a look at these. You can pause the video if you need to go over them and then move on when you're ready. All right, let's take a look at example 1. Example 1 says, a landscape company wants to plant lawn seed. A 20-pound bag of lawn seed will cover up 420 square feet of grass and cost $49.98 plus an 8% sales tax. A scale drawing of a rectangular yard is given. The length of the longest side of the yard is 100 feet. The house, driveway, sidewalk, garden areas, and utility pad are shaded. The unshaded area has been prepared for planting grass. How many 20-pound bags of lawn seed should be ordered and what is the cost? Now, there's a couple different steps to this problem. It's fairly complex, so let's think about what is some of the first things that I need to determine. You do have a couple options here. I'm thinking that the first thing I want to know is how long is each side of these individual cubes? And I can do that by realizing that I know that the full length of this entire side is 100, and if I count up how many blocks there are here, that can help me to figure out how long each block is. So if I count those up, I find that there are 20 blocks. So I know that 20 blocks is equal to 100 feet. So if I want to find one block, essentially what I'm doing is finding a unit rate. So I'm going to divide both sides by 20. And that gives me one block is equal to 5 feet. So that tells me that each side on a block is 5 feet. So now I want to know how much grass seed I'm going to need for each one of those blocks. So that's really an area. So the area of a single block is going to be the length times the width, but it's the same. So we would say 5 times 5, or 5 squared, is going to give us 25 feet squared, or 25 square feet. The next thing I need to know is how many of those blocks do I have in this figure? And I could go through and count them individually, but that could take a long time and I might mess up. So I really want to have a systematic way of doing this, and a great way to do this is actually to divide this up into smaller rectangles and then finding the area of those rectangles. So if I divide this up into smaller rectangles, for example here, this is a width of 5 and a length of 10. So 5 times 10 is going to give me 50 blocks in this one. I can see there's 8 here and 45 here. 9 blocks here, 4 blocks here, 12 here, 80 blocks here, and then 12 blocks here. So let's add up all of those numbers together so we can get a total number of blocks that we need to account for. So we have 50, 45, 9, 4, 12, 80, 12, and 8 for a grand total of 220 blocks. So if I have 220 blocks that need to be seeded and they each cover 25 square feet, I need to multiply those two together to get my total square feet that we're going to need to cover with grass seed. So I'm going to multiply 220 by 25, and that's going to get me 5,500 square feet. Okay. Now, if I go back and look at the problem, they told us that one 20-pound bag, will cover 420 square feet of grass. So I am going to take that amount and do our total amount of grass, or rather land, that we need to cover, which is 5,500. Oops. Feet squared, and divide that by what each bag will cover, which is 420 feet squared. So my feet squared are going to cancel, and that leaves us with approximately 13.1. Now, if you think about it, you cannot buy 13.1 bags. So if you need to have that 0.1, even though 0.1 normally tells you to round down, you still need to cover that amount of land. So logically, we would need to buy 14 bags. Now that I know the number of bags I need to purchase, I need to figure out the cost. So if I look at my cost per bag, it's $49.98 plus an 8% sales tax. So first, let's figure out just the main cost of it. So we're going to take $49.98 and multiply it by 14. And that gives me a cost of $699.72. And then I need to figure out the sales tax. And we've talked about all year long that you can break this up into two different steps by finding 8% of our total cost and then adding it back into the original cost. But we also talked about shortening our steps. And we can do that by realizing that the $699.72 represents 100% of our costs. And then we have to also pay an additional 8%, meaning we're paying 108% total. Well, that would be 1.08 times our cost. And when I multiply those two, I get a final answer of $755.70. Now, this is a word problem, so I want to give a worded answer. So we'll say the company should buy 14 bags for a cost of $755.70, and that's my final answer.